Welcome to the lecture series on object oriented analysis and design. So, we have understood so far in the earlier lectures the idea of requirements, analysis, design, how the object oriented paradigm is helping us do better than what was done earlier. Again, we must mention that it did not happen out of the blue. We have learnt our lessons the hard way. 2 to 3 decades of grind in software engineering made us understand that if we take on to these ideas which we have been discussing in the object oriented paradigm, then we are likely to do better. Better means what? People productivity, people at all levels, the customer, the developer, the people who are holding a stake, the users, whatever you want to take or whatever you want to talk about. A lot of people, it is not about machines. Software engineering is not about machines, it is about the people. Their productivity should increase. So, for the kind of an effort that has been put in, what is it that we are getting out of it? So, if we can solve the problem better, we can make sure that using this solution the productivity enhancement is clearly seen. We are very happy about the progress. The development paradigm is a wonderful paradigm. We are not able to come up with a development paradigm that will be able to do this for virtually everything that people want to do with machines and computers. It is difficult. So, object oriented paradigm has established itself on certain grades of complexities. Let us say, if nothing else, 1 lakh lines of code, minimum 1 lakh lines of code is a complexity that we look at, and in certain application areas where we have been talking about vending machines or where the componentization is obvious. I work in the field of open source, so we talk about so many problems, so many open problems. We do not have a paradigm, we do not have a surefire solution. There are certain open problems which we keep attempting. Suddenly somewhere the spark will come and then we go ahead and work further. It's a nice experience, a humbling experience to throw out problems into the open and then see that the spark is coming. It's a good idea to try it out. So, there are so many open problems. Out of the problems which we think are solvable using the computing, we have had certain paradigms. Out of those problems, a certain class of problems are nicely amenable for solving using object oriented. Now, this object oriented should not be tied up to any specific language, C++, Java, so many languages are there, Ada is there, Java is there, and a compiler is there for that language. It can be an intelligent compiler, it can be an optimizing compiler. All these things put together simply mean that there exists a very good class of problems with object oriented analysis and design, and a development paradigm called object oriented paradigm will certainly enhance the people productivity. The development will happen at a faster pace, people will adopt the solution faster. So, this is what we have been trying to do. Problem solving, defining the system, it can be done by the non-programmers, they need not be programmers. Analyzing the definition, study definition for thorough understanding, decide what details are necessary and unnecessary. If we can do this, it is great happiness. Most of the times neither the customer knows what is the problem so clearly, nor the developer knows what is the problem so clearly. Therefore, the more we get focused on problem and take technology a little later, the better it is. Oftentimes in this process, we either forget technology or we have taken so much time trying to see the problem that whichever technology comes we will use it. So, the balance of what is it that we are doing, pacing out of the things, for this we need a life cycle, we need a software engineering methodology, we need a software engineering process, so that we do not spend time unnecessarily on various things. Decide what details are necessary, unnecessary, and then take it forward to a detailed system specification, complete statement of what system and all its pieces model. It is not merely the big picture, the smaller parts of that big picture are also essential. Drawn from analysis of definition, defines how user will interact with the system via user interface, designing the system. System is composed of smaller subsystems, which in turn may be composed of even smaller subsystems. This is what we think normally. We keep telling, using the same term, divide et impera, that simply means that divide and conquer. In many cases, that is a simple way of understanding what we are doing. There is a big problem, we got a model. Based on the model, if you break down into subsystems, they all fit into the model. The model is telling us that this is precisely what is expected to be solved, and if that model is in conformance with object oriented analysis and design, our idea is falling in place. The objects are in place, the way we are building is in place. The model itself is an object. System is composed of smaller subsystems, which in turn may be composed of even smaller subsystems. Pseudocode, somewhere between English and high level language, describe tasks, subtasks and how they relate. It is a slightly old world idea to spend time on pseudocode, hand simulation, desk checking pseudocode by stepping through it without using a computer. Now, all these things are there. So, what we have been doing is very simple. We said that system is composed of smaller subsystems. It depends on the confidence you have in the model. So, when we were doing in the earlier structured method, we simply said that let there be a pseudocode, let there be a hand simulation, everything should be there. But now we are confident about the model, and if you know how to do a model checking and model verification, very soon we will get into the designing of a system. We may not spend time with pseudocode and hand simulation, but then we can simply describe our model, unified modeling language. Implementing the design, emphasis on good problem decomposition, well structured design and readable, well documented programming style. Hand simulate as you go, may need to backtrack and redesign. Now, all these things were happening earlier. The problem solving was there right from the moment when we started using computer for some function, for some functionality, for some purpose. However, some of these steps are now eased out if the paradigm chosen is object oriented analysis and design. They are happening, but then the paradigm is giving you an assurance that since you have done the model like this, all these things are automatically taken care of. You can simply rely on a tool. So, instead of human intervention in doing pseudocode, hand simulation, programming style, hand simulate, you can bank on a tool. They are good tools, you can simply run through the tool. That is how it is. So, what we have done is testing and debugging will now roughly take the same time, but by reducing time on the other aspects which are also necessary in problem solving, we are able to spend more time on the design. That is the way the paradigm has helped us shift the focus here. We are only on problem solving slide 1, analyzing the definition, and 2. After this, we have a way of automating, we have a way of quick checking all these things. We do not spend too much time on this. The modeling, the object oriented analysis and design is so fast that we can simply go to the testing and debugging. We cannot do away with testing, we cannot do away with debugging, but then without encroaching too much into the testing phase, we are able to make sure that the design phase is increased in time, and spending more time on the design will reduce time on the coding. That is how we started apportioning. We are able to focus on the design. That is why we need a life cycle, that is why we need a software engineering, that is why we need a practitioner's approach. Working program will come, it solves the original problem. All this is fine, but what are we doing to manage complexity? We talked about so many paradigms. One of the paradigms is object oriented paradigm. You see, there are 8 popular paradigms, each having a focus, and by saying so, I am not telling that these paradigms are completely independent of one another or watertight compartments. They share very many concepts, they share very many good ideas. The vast experience that has been put behind is very, very essential in choosing a paradigm. We have for this lecture series chosen to focus on object oriented. There are other paradigms. There are good concepts, they relate to each other. Good practice is, once you have chosen a paradigm, please adhere to the paradigm. It will at least take you up to 36% success rate. Imperative programming, object oriented programming, functional programming. Yesterday I was mentioning in earlier lectures, functional programming is there, logic programming is there, event driven programming, concurrent programming, distributed programming, database programming, about 8 popular paradigms. We did one theoretical analysis. Around 27 programming paradigms are possible that can allow us to work with the stabilized standard concepts which can take us to the machine without going into the dark ages. We are not going into doing the machine wire diagram, nuts and bolts, but at a higher level, reasonably higher level. We have seen people who have been doing machine language programming, zeros and ones. We have seen how difficult it is to go any beyond 200 instructions. 200 instructions is hardly about 10 to 15 lines of code today. We have seen the progress from machine language to assembly language to third generation or high level language, fourth generation language, fifth generation language. We have seen so many nice ideas that have come into the world of programming. Learning programming languages and scripting, the principles are so nice that this many principles are well established. To make best use of these principles, what kind of combinations can happen? We think roughly 27 computational paradigms are possible. Out of 27 today, there are 8 which are very, very popular. We come across all these paradigms very frequently. Sequential execution of instructions, this is what we excel in. Please tell me what to do step by step, I will do it. However, this sequence is operating elsewhere. Suddenly what happens if there is rain? I won't know. I am independent of the rain, it is not going to impact me. Suddenly what happens if power fails? Yes, it impacts me. So, sequential execution is nice, we are all well accustomed. I have my good colleagues who have tasked themselves very clearly. I am doing my task, my colleagues here, 3 or 4 people here, they are tasking themselves, parallelly things are happening. Sequential execution of instructions, use of variables representing memory locations, use of assignment to change values of variables. 3 major topics of object oriented programming, as I was mentioning: polymorphism, inheritance, encapsulation, state and behavior. These are the characteristics of object oriented paradigm. Minimum is this much. We need to understand that there is a data encapsulation which tells us very clearly, even if you want to, you need not find out what is happening inside. From what is going in, what is coming out, it becomes very clear for you to imagine, to figure out what is the state, what is the behavior of the object. We do not have to break open everything and understand how it is working and then use it. It is not necessary at all. So, data encapsulation taught us a nice way of working with black boxes, working with things which are simply called unknowns. As a matter of fact, the entire field of programming and software engineering is so intellectually challenging, because at every step it is a puzzle, stepwise refinement. Only if you want, if you get adequate data, you refine that block. In theory, we are always accustomed to working with black boxes, unknowns, incomplete data. So, the very reason why requirements is being projected as a number one villain is because of this fact. They change. Change is too fast in the field of software engineering. We promised that it is a very elastic way of working. Nothing is frozen. There is nothing called frozen requirements. However, best of the engineering principles work when there is a frozen requirement. So, what we have done therefore is that this idea of componentization, yes, this is a component, you encapsulate and keep it. You can infer, you can figure out, you can find out what from what is going in and what is coming out, what is the state, what is the behavior. Again, this is not a solution for every problem that we think of. A good class of problems with a complexity metric of a lakh of lines of code plus above lakh of lines of code are remunerative, cost effective, they give good return on investment. So, that is how we have been positioning this idea called object oriented. Functional programming bases computation on evaluation of functions. No notion of variables or assignment, repetitive operations are done by recursive functions. How is this happening? We keep giving the example of what John McCarthy did, list processing. There are 10 things to do. I may not be able to do anything now. After half an hour, 2 things are possible. I will choose one. In a given day, I want to complete a list of 10 tasks. Tasking is one, 10 tasks which I have to complete in a given time is the next problem. So, such problems are very nice to solve using functional programming, and we realize that AI, artificial intelligence, requires this kind of a way of working. Then came the next one, logic programming. Logic programming is based on symbolic logic. A logic program is a collection of declarations which are true about the desired result. So, for example, we started talking about 20 rules. Can I, for example, do this lecture within my university? How will the rule base tell? Yes, there is a procedure, there are a set of rules which we are following, there is a director who has assigned this task to me. Independent of the people, it can be verified that this lecture can be done in the university like this. I can use there are so many conflicting rules. For example, right now it is a lockdown condition. That question is a valid question. So, we talk about a rule base within the framework, within the administrative structure of this organization. This is how this lecture is happening. Who will conclude? How will we conclude? If the rules are so clear, if the rule base is so clear, logically I can infer yes or no. It is possible or not possible. So, no notion of flow of control, it is just an analysis of rule based. Event driven. In this case, there is only one event staring at me. However, most of you would now be experienced on having multiple windows opening. One of that is all that you are using, other 10 windows are not there. Only when you go to that window as an event, it is triggered, otherwise it is doing whatever it wants. So, multitasking, task sequencing, all these things have become very important in the present day life. Machines have become faster. To justify that speed, that capability, that sophistication, we have been using more things. In summary, every programming paradigm aims at improving the people productivity, but then there is no single paradigm that is guaranteeing all the productivity increase in whatever people want to do. That is not happening. We take recourse to the problem. Depending on the problem, we choose a paradigm. We are happy that there is a good number of application programs that are nicely impacted, visibly impacted by object oriented paradigm. AI had its own way, ups and downs. List programming, logic programming, rather functional programming and logic programming had a good spell in the very first attempt of AI. Second wave been spoken of. Now, again the third wave is coming, but we are not talking about the paradigm. These days it is all about machine learning, the existing content is there, so many things are there, we are going ahead, but then we are not so much focused on the functional and logic programming as we were in the very first spell, very first wave of AI. Event driven programming is an everyday experience. You have 10 windows open, only one window you are executing wherever the event is. Concurrent programming, parallelly so many things are happening. Distributed programming, I am not going to talk about these things much, but we know that the network is a computer. You need not really have a supercomputer, but you can have several smaller computers giving you the same impact, same speed, same efficiency. However, the way of coordinating amongst these smaller computers requires ideas on synchronization, messages, remote procedure calls. So, these are certain characteristics of the paradigm. So, as I kept mentioning, about 8 programming paradigms are now very popular, of which object oriented is still reigning supreme, because it is a programming intensive exercise and we are talking about complexity. So, in the field of software engineering, we learnt to manage complexity, primarily by developing these computing paradigms, programming paradigms. A problem description, again multicolored, some are objects, some are relationships. Deposit, withdraw, transfer are all relationships. So, we talk about simple language, a procedural approach, focuses on procedures, all data is shared, more difficult to modify. There are difficulties. Here the focus is on what to do. Somebody wants to deposit money, puts into the account, gets back, or withdraws money, puts into the account. They are not worried about the other task. The goal is only on the money deposit. I need not know anything about the ATM. So, what we have done therefore is that object oriented with data encapsulation, that is what I am trying to tell, that the ATM is just there. I do not even need to know who made it, why it is made, why it is there. As long as it takes the card that I am having and enables the withdrawal of the money, I am quite contented. Protection, consistency, and allows change. Now, what is the basis of this? As I mentioned in one of the lectures, Peter Code and Edward Youdon have given the very first and a very nice method that makes us move from a structured programming to object oriented programming. By saying so, I am not telling it is complete, it is very comprehensive, it is the best. It is definitely not that I am indicating, but then how do we think differently all of a sudden? 2 decades we have been talking in one manner, and how do we make sure that we switch to this object oriented? So, Peter Code and Edward Youdon straight away in the very first chapter, they draw our attention to something which Encyclopedia Britannica has included, that is called classification theory. It is a very good theory, its source is in Britannica. So, most of the times we think that in apprehending the real world, people constantly employ 3 methods of organization which pervade all of their thinking. If we can understand this thinking, then we are understanding what is it that is different in object oriented. So, our thinking must be oriented towards the differentiation of experience into particular objects and their attributes, when they distinguish between the tree and its size or spatial relations to the other objects. A tree has a uniqueness. If you can distinguish a tree and keep it aside, first things first, this is a different tree. There are so many trees, this tree is different. The distinction between whole objects and their component parts, when they distinguish between the tree and the branches. The formation of and distinction between different classes of objects, classes of trees and classes of stones. Trees are not stones, they are different. Now, whether we like it or not, we must acknowledge that this is how most of the times the infants do the exercise. They classify things, they try to segregate. We think that it is a very natural way of looking at the real world around us. If we know how to differentiate, if we know how to distinguish, if we know how to make the distinction between different class of objects, then yes, we are solving a problem. We need that classification theory to do better problem solving. It may appear that why are we classifying, everything can be there, it can be a potpourri of many things, everything can be jumbled. Problem solving requires that structuring, and we have been always telling that object oriented is something different. C++ is not C++ something, it is a completely different way of thinking. What is that different way of thinking? In a limited way, well scoped, Peter Code and Edward Youdon in their book have included classification theory, which is expressed so nicely in Encyclopedia Britannica, a source which we do not normally think of, but that is how it is. So, object concepts, we continue to explore the question what are good systems like by describing the object oriented paradigm. These are all difficult questions. We spent good 2 lectures or even 3 lectures on object identification and modeling. It is not that we are simply understanding that it is different. Classification is that in real life, yes, the tree and the stone are different. Nature dictates it like that. It is not such a big supercomputing ask. That is why we keep drawing attention to the fact that it is a toddler's task. Apples and oranges will be separable by a toddler. but then in real life these objects are so tangible. Even today I can be accused of telling that teaching object oriented in my case is banking more on tangible objects, objects that you can see, objects that you have a look and feel for. We are talking about abstract objects. The problem is not talking about tangible objects. It is a problem space which we are talking about, of which fortunately there are some tangible objects, but many of them need to be recognized, identified, modeled. So, had all the aspects of problem been so tangible, we could have figured it out ourselves how to solve it. There are certain things which are not so tangible. What is an object? How do objects communicate? How is the object's interface defined? What have objects to do with components? Finally, we consider inheritance, polymorphism and dynamic binding. All are difficult questions. Good 3 lectures happened on object identification and modeling. That is the most difficult aspect. We are always being accused of telling that we are very quick in telling anything can be an abstract object, if not today, tomorrow. Like we have been telling, today the technology may not be there, tomorrow it can happen. So, we need a structured way, we need a way of working in terms of verification, validation. Only then people productivity will increase. People productivity simply cannot increase just like that. Take a whip and tell that you do 10 times. No, it does not happen like that. Do not think of what an object holds, but what it will do for you. Earlier on, what was our idea? This is a data item. What is it holding? Integer. What is it holding? What is it representing? The first change is we should find out what is it doing for me, what are the actions possible on this integer data item. Consequently, no public data members think only about the methods. An object may represent something in the real world, but often not. Conceptually, an object is a thing you can interact with, you can send it various messages and it will react. Depending on what is sent and what is received, we know what exactly is happening in the object. It is the first lesson which we learn in the distributed paradigm. The sequencing is no more our strength. They come at some time, we do not have the control on the network, they are time stamped, but then the way in which they have been communicated all over is not the real sequence. It is not a sequential program which is our strength. A very first lesson which we learn in distributed programming paradigm. But however, as I said, distributed programming is for a bigger exercise in this idea. We are only contented with objects, what is the message that is sent, how it is reacting. How it behaves depends on the current internal state of the object. So, objects have 5 ideas. To summarize, objects have 5 ideas: inheritance, polymorphism, data encapsulation, state and behavior. If you are confident about these 5, that object will have an identity. Later on we will tell that there are so many objects like that which can form a class. It matters which objects you interact with. An object has an identity which distinguishes it from all other objects. Tree is not the stone. When can you tell that? When it has an identity in your mind. So, that is how we have said object, if identified well and modeled well, will give us all these things. Then you can put together the objects. If you are well tasked in your mind, you can find out. The Meccano tells that using these 30 components, some of them will be useful, not all in every artifact, some 20 models can be constructed. It is a good fun time event. If you want to add a few more components of your own, you can do. If you want to get a 21st one, you can try. Today it is not there, tomorrow it may be there. Today you are not familiar with that, tomorrow it may happen. So, therefore, what is it that we want to do? We want to simply make sure that the OOAD will focus on productivity, people productivity, machine productivity, all these things are kept in mind, but what is the emphasis on? People productivity. We should solve the problems faster, we should solve the problems more efficiently, we should develop the program faster, we should develop the program more efficiently quickly we should be able to test all those things that I have been talking about on people productivity. Thank you. We will meet in the next lecture.